Well, hello. Welcome to scaling up to your first 10 million users. I actually have a big treat for you today. We're going to raise the bar for this session, and we're not going to scale to 10 million users, but we're actually going to scale all the way up to 11 million users. Pretty cool, huh? Yeah, thank you. So a little bit about myself real quick. I don't want to spend a whole lot of time on this. My name is Joel Williams. I'm a solutions architect for Amazon Web Services. Been doing this for a little over 3 years now. Before coming over to AWS, I worked at a healthcare claims review company, managing the infrastructure from the network level all the way down to the printers. I mean, if it plugged into a wall, basically I was responsible for it. You guys, hopefully you're here, you're obviously looking to scale your web applications on AWS, but I imagine you're probably at different journeys of your Amazon Web Services journey, I guess. And to say that means that some of you are running production workloads on AWS, some of you are probably running some test and dev, and I understand that. So I need to do a little bit of level setting, at least to get started. I'm going to brush through this because, lucky for me, Andy included a lot of this during his keynote, so we'll kind of go through it quickly. You're asking yourself, though, how do you scale, right? That's the fundamental question of this talk, so I'm going to answer that for you. If I'm looking to figure out how to do something, the first thing I'm going to do is go pull up my favorite search engine, pull up my favorite web browser search engine, and I'm going to type in scaling on AWS, right? That is a lot of stuff to read. And I'm going to suggest to you that this is not where we want to start. Autoscaling is a tool and it's a destination. We're going to get there eventually. But we don't want to start there. We have to do some things to our infrastructure before we're in a state that's going to really make sense to leverage all the capabilities of autoscaling. It's not that single thing, even when we get there, that's just going to fix everything. We need to do some things first. So those basics that I promised you we'd talk about, first of all, you need to know that we have 11 regions around the world. I'm also going to throw in India there because we did pre-announce that one last year at this time. And within those regions, we have the concept of availability zones. And this is going to be an important aspect for you, not only as you scale your architecture, but it's going to give you some abilities that you traditionally don't have in an on-premises environment to actually have some high availability. All of our regions are built out with at least 2 of these availability zones. And we have many services that leverage the multiple availability zone architecture, but we also allow you then to use those multiple availability zones to architect your applications for that high availability as you scale. The last piece of the global infrastructure I need to point out is our edge locations. We currently have 53 edge locations around the globe. And just like our regions and availability zones, our edge locations is an area of our infrastructure that we're constantly expanding. So it's 53 today, it might be 54 tomorrow. And that's important because these edge locations are used by 2 of our services, our content distribution network, CloudFront, as well as our Route 53, our managed DNS service. And that gives your users the ability to get their content at a very low latency globally. Andy showed a slide that looked a lot like this in his keynote, so I don't want to spend a whole lot of time on it other than to say that we're not talking about all these services today. You can use these services and these patterns to scale, but we can only go into a few of them, obviously, in 60 minutes. So the area that I want to focus in, most importantly, is that one in the lower left corner there. To me, that's the most important thing, right? Anybody agree that this is the most important part of our service? Okay, I needed a couple laughs. Thank you very much. Actually, we're going to talk about services that fall into these little buckets here. I've talked about the regions, the availability zones, and the global infrastructure, but obviously we've got a bunch of fundamental foundational services there at the bottom that are going to be very important as we scale, as well as a lot of those application services there on the left. Later on in the talk, we're going to talk about decoupling, and those services are going to come into handy there. So this multi-availability zone architecture that we have gives us the ability to build out a number of services that you get to leverage that are inherently fault tolerant because they leverage the multiple availability zones. These availability zones are physical locations that exist within a region. Think of them as data centers, but sometimes they actually comprise of multiple data centers, but they're separate enough that they've got separate power, separate internet pipes. The only connection they have is a low latency connection between each other so that you're able to architect your applications as if they exist in the same physical location, but yet they're actually separated by like 5 or 15 miles from each other, so that now they can withstand the availability issues of one area. Very important. So the services that I've listed on the right of the screen there, those are services that exist within an availability zone, and we're going to work with those today. But I'm going to show you how you can leverage those services to create a highly available architecture, even though those services themselves exist only in a single availability zone. So we want to get to 10 million or 11 million users, as I promised you. We're going to start from day one. And usually day one is one user, right? And that's you, right? You're building your infrastructure. You need basic components to start your, to get a web application up, and you're the only user that's going to use it. So at a very minimum, this is what your architecture is probably going to look like, right? You're going to have a single instance that's running your entire web stack. You attach an elastic IP address to it. You put an entry in Route 53, our managed DNS service, so that you have a way to not type in an IP address to actually get to your infrastructure and use a fully qualified domain name. And this works, right? This is a fully functional web application that will service your needs, at least with you as a user. However, at some point, we're going to need a bigger box, right? We might have started with a T2 micro, but we need more compute power. And that's the simplest approach to scaling, right? Just choosing a different instance type. And we make it really easy for you to do that, right? You just stop the instance, choose a new instance type, and wham, you're running with new compute power. And we can provide you with a whole lot of stuff. I can give you a system with 244 gigs of RAM, 2 terabytes coming soon, or I can give you one with 40 cores of CPU. I mean, we can give you a lot of stuff. But we're going to hit an endpoint at some point. We can only get so big, right? At some point, we have to do something else. And this architecture, as we scale what I'm going to call vertically, this can get us pretty far. We can do a lot with this vertical scaling. It does have some inherent problems, as you've probably noticed. There's no failover, no redundancy. We've got all of our eggs in that one basket. That single instance has our entire web stack, right? The database, the application logic, the web server. It's all confined in that one instance. That obviously has some problems that we need to address, and we will. So the goal here is to get to more than one user, right? It's great that you can log into you can hit your web app and everything works fine, but at some point we're going to need to get somewhere more than one. Maybe it's the 10 users I just popped in here, maybe it's a little bit more. And I'm going to suggest that this might be the time that you start to think about taking your database and moving it off of your web server. Don't put all your eggs in one basket. This is going to give us a wonderful ability now to scale the tiers of my application independently from each other, right? I can scale. They have different needs. My website has different needs than my data, so why not break them apart and scale them independently from each other? And I'm also going to suggest that this is the right time to start thinking about using a managed database service. Most people that are architecting web applications on AWS, they're not database administrators, and they don't want to deal with those mundane tasks of managing a database, whether it's the backup or the high availability. And we have tools that you can use to help in that regard. So I'll get to those tools in a minute, but this is the time where you really want to start thinking about that. These tools, so the left side there, yes, you can put your database, whatever database you really want to put on your EC2 instance, and manage that yourself. Of course, now you're not only managing the database, but you're managing the underlying OS and everything that goes with that. If you want a fully managed database, we've got a number of options for you, right? We've got the Amazon RDS, and I must point out that we've got 2 newer services in Amazon RDS, the MariaDB, which we just announced yesterday, right? And then Aurora. I've got some more data on Aurora on the slide that follows this one. And that's just that's a relational database service. So in this particular case, you don't have to worry about the backups, the patching, all those mundane operating system tasks that you need to worry about when you are managing a database on your own, as well as the ability to create multi-availability zone architectures. That's huge. You can literally have a highly available database with a single click, and you don't have to manage the replication. Huge benefit. Amazon DynamoDB, that's our NoSQL managed database. Again, you can run a NoSQL database on EC2 and manage all that yourself, or you can leverage Amazon DynamoDB. And then, of course, Amazon Redshift, which, as Andy mentioned in the keynote, was our fastest growing service in the history of Amazon Web Services, and it's our petabyte scale data warehousing platform. Just a little bit more about Aurora, because it's very popular and it's becoming a fast growing service for us. Being able to dynamically scale up to 64 terabytes. So I no longer have to provision the storage for my data. That's huge, right? Because typically if I provision storage, I'm now obviously paying for that provision storage, and I might not be using all that storage. So with Amazon Aurora, we give you the ability to dynamically scale and up to 64 terabytes, which is awesome, totally awesome. And then the other stuff, you can read that on your own, but I do want to point out the 6-way replication. So taking advantage of the multi-availabilities in architecture and making sure that you have multiple copies of the data all over the place so you can withstand failure. And that's going to be also extremely important as you scale out your application. So you have to make a decision. Am I going to use a NoSQL database, or am I going to use a traditional non-relational database? And a number of you aren't going to like this in this room, but I'm going to suggest that you start with a traditional relational database. And the reason here is that it's well-worn technology. There's a boatload of information on how to scale these databases, on how to interact with these databases, lots of support groups. And you're not going to break this database in your first 10 million users, most likely. I've got a little star there, right? I've got that little asterisk, which basically says, you might be doing something funky with your data that's going to require you to use a NoSQL database, but those are edge cases. So for the majority of you, I'm going to say, start with your traditional relational data store. Okay, so you're one of those people in the room that has a massive amount of data. And you're like, oh yeah, I'm the edge case. I'm the one guy in the room that probably should start with a NoSQL database. Okay, so if this is you've got the massive amount of data, or you've got a super intensive data workload, then okay, I'm not going to argue with you. It may be the right place to start. Why else might you need to start with a NoSQL database? Again, you have the massive amount of data. You need the really high throughput. You need to be able to really tweak the IOs that you're getting, both on the reads and the writes. Maybe you don't have any relational data, right? You're not doing any complex joins, and there's just really no reason for a relational database. That's a possibility as well. Okay, so we want to scale. Obviously, that's the title of the session. How do we get more people? Let's put those 100 people there quickly. Beautiful. So I've decided that I'm going to take my my database, and I'm going to put it in the Amazon RDS platform, because I don't want to manage those mundane tasks. And so I've chosen an RDS database, and for the purposes of this presentation, we're going to call it a MySQL database. Look at that, 1,000 users. Awesome, we're just moving right along. So at the beginning when we talked about vertical scaling and we had all of our eggs in one basket, I mentioned that we have some problems that we need to address. And one of those problems is going to be the availability of that application, right? If that one single web server goes down, we've got a problem. So I've added a few more things to this architecture to help this out. The first thing I've added is that the other web instance, right? And I put it in another availability zone. That's a really important concept. I didn't put it in the same availability zone, in another one. And that's okay, because the latency between those availability zones is in the low single-digit milliseconds. It's almost like they're in the racks right next to each other. That's awesome. I've also added a slave database for my RDS implementation. So I now have a failover database for my MySQL relational database, so that if there's some problem with the master, my application can automatically switch over to the slave. And by the way, there's no application changes that you need to make, because it's the same endpoint. It's the same connection string. So your application doesn't have to be aware of that slave. Finally, you'll notice I threw in the ELB balancer, right? The Elastic Load Balancer. And that's another important part of this puzzle, because my users want to be evenly distributed between those two instances in those two different availability zones. And the Elastic Load Balancer is going to give me that ability. A little bit more about that. The Elastic Load Balancer is a highly available managed load balancer. So although you noticed in the previous slide, it looked like I had one load balancer kind of in between two availability zones, it actually exists in both. But I put it there because logically it looks to your application as one Elastic Load Balancer. So it's a single DNS endpoint for you to throw into Route 53 and navigate your users to. But if you've got services that exist in both availability zones, Route 53 and the ELB are going to make sure that it goes to both web servers in the two different availability zones. My favorite feature of the Elastic Load Balancer is the health checks. So that you configure a health check on the ELB so that if the ELB then determines that an instance that's behind it is not healthy, it's just not going to distribute traffic to it anymore. So that's also very important. So this horizontal scaling that we get with the Elastic Load Balancer and the vertical scaling that we get with simply choosing a new instance type, this is going to get us pretty far. Okay, we're going to be able to get to the hundreds of thousands of users. But and this kind of explains part of why we can do that, because although I only showed two instances behind that ELB, really I can put thousands of instances behind that Elastic Load Balancer. I'm showing 4 in 2 different availability zones here, but you can think of this as going out horizontally as far as the eye can see. And also notice I threw in a couple other Amazon RDS concepts here with the read replicas. So I'm going to take some of that load off of my write master and get it off there, right? Let my master handle writes, let my read replicas handle all the other traffic. It's going to be really important to me as I scale. We also need to consider performance and efficiency. There's some things that we need to do to tweak that. And I'm going to do this by lightening the load on the tiers of my application. So the first thing we're going to do is we're going to move some static content that exists in my web app. I'm going to put it in Amazon S3, and I'm going to front it with Amazon CloudFront. And just as a reminder, CloudFront is one of those services that leverages the 53 edge locations that we have around the globe. Again, that's a current number that's constantly expanding. I'm going to dive a little deeper into these services. So Amazon S3, it's an object-based store. It's not the type of storage you attach to an EC2 instance. It's not that type of storage. It's an object store, not block store. But it's a great place to put all that static content. Your JavaScript, your CSS files, your images, your videos, all that stuff doesn't need to sit on an EC2 instance. It should be in an object store, in Amazon S3. It's highly durable. 11 nines of durability is what it was designed for. It's infinitely scalable. You can throw as much data at it as you want. We have customers storing petabytes upon petabytes of data inside of Amazon S3. And give us objects up to 5 terabytes in size as well. You can encrypt it using our encryption, using your encryption. We actually have encryption services that you can leverage. The key management service, for example, to actually manage your keys for the objects that you store in S3. And then CloudFront, that is the cache, right? You want to get that content out to your end users as quickly as possible. You want to have the very lowest latency that you can to those end users. And CloudFront is that ability to do that. I can cache my static content at those edge locations to get it there quickly. And you can see now that I'm lightening that load on my web tier, right? I'm taking that off of my web tier and getting it out to these edge locations, and it's going to really help me scale. Couple charts here. I mean, they're pretty basic. The top one showing you that, hey, if you don't have a CDN, you're going to have high response times and high server load. Versus, the middle one there. I've got a CDN for static content, and my response times and my server load is obviously going to go down. And then notice on the other one, I've listed dynamic content, because although CloudFront does do static content delivery, it also does dynamic content delivery, and I'll dive into that a little bit more as we move along. And then the bottom one is actually a graph that shows a real customer that was leveraging CloudFront. And they had a need to get 60 gigabits per second out of their application. And the web tier didn't even blink. They didn't have to do anything, nothing. CloudFront was able to absorb all that and deliver the content to the end users. That's huge. Huge value there. So the other thing I want to look at is getting my session state off of my web tier. That's going to do a number of things. Obviously, it's part of lessening the load on that web tier, getting the session data off, and sticking it either in Elasticache or, as I'm suggesting here, DynamoDB. And the other thing it's going to do is it's going to be one of those things that's going to help us get to that auto-scaling that we saw at the very beginning when I typed in on my browser search. The next thing is actually using Elasticache. Again, this is now going to help me with getting data off of my data tier and lessening the load there. If I've got content that's getting read all the time, it's the same content, put it in a cache. I don't need my database handling that. Elasticache is our managed service for taking care of that. So DynamoDB, a little more about that. Yes, this is our managed NoSQL database. You actually get to provision the throughput that you want. You're dialing up the amount of performance, the reads and the writes separately from each other. So really powerful there. I can really create a database infrastructure that's highly performant. It's a key value pair, a key value store. We also support JSON documents and documents up to 400 kilobytes as well. One thing to point out also that this is one of those services at the beginning I said that is inherently fault tolerant, right? It exists in multiple availability zones so that it can withstand the issues in one availability zone and still provide value to your application. Elasticache is a managed Memcache or Redis. And again, when we're looking at something like this, you can run Memcache or Redis in your own cluster, and you can manage those clusters on your own in an EC2 instance. But I'm suggesting that that's probably not it's not differentiating you. Your ability to manage a Memcache cluster is not making you more money. So consider letting us handle that. Put it in a managed service, and then you don't have to worry about the management of the clusters. We will automatically scale the clusters for you. And also, we've got, it's a self-healing infrastructure so that we can detect when nodes are no longer working and bring up new nodes to replace them without you having to worry about it. And then the final thing is, again, that dynamic content that I mentioned earlier. The CloudFront has the ability to cache not just static content, but dynamic content. And that's going to be a huge value, again, for being able to lighten that load on your web tier. So now that we have a web tier that's much more lightweight, this is the time to start going back to the beginning of our talk. And we can go to auto-scaling and at least start to make use of that. So what is auto-scaling? Again, it's not that magic button you push and then everything just scales and away you go. But it does do automatic resizing of those compute clusters that you create. You get to define the minimum and the maximum size of your pools. So as a user, I decide what's the smallest number of instances I want in my cluster and what's the largest number of instances I want in my cluster. You use a service that we have called CloudWatch, which is our management service, and it's embedded into all of our applications. And CloudWatch is that tool that you use to let your auto-scaling group know what that event is that's going to make you scale. Are you going to scale on CPU utilization? Are you going to scale on latency? Are you going to scale on network traffic? What are you going to scale on? Well, CloudWatch is that piece that you tell what you want to scale on. And you can actually push your own custom metrics into CloudWatch. So that's huge, right? If you want to scale on something that's application specific, you can push that metric into CloudWatch and then tell auto-scaling, I want to scale on that particular custom metric. Another great value. Just for kicks, I threw in a little bit of what the different pieces of the auto-scaling configuration look like. It starts with that launch configuration where you basically define what is the instance type that I want to launch, where am I going to put that instance type, what availability zone, that kind of thing. The auto-scaling group, that's where I am defining what are my parameters, what's the minimum, what's the maximum that I want to get to. And then, of course, the auto-scaling policy is what's that event that's going to trigger my auto-scaling group to move up or down, and that's obviously an important part, right? So if you look at this graph, this is the typical weekly traffic to Amazon.com. This was taken from a sample in November. This might actually look a lot like what your traffic looks like, spiking during the day, going down at night. It's a typical traffic, not just to Amazon, but to other places. And if you wanted to provision enough capacity, you might say, give me 15% more than what I'm going to peak at. I'm going to provision that capacity, and your application is probably going to behave okay. But what about November traffic to Amazon, the whole month? We've got Black Friday, Cyber Monday. That's a huge spike. And if I had to provision that much compute power, I'd be wasting a whole lot of money, a whole lot of compute power that's sitting around doing nothing for most of the time. Wouldn't it be nice if I could always make sure that my compute power matched the demands of my application? Well, yeah, that's exactly what auto-scaling lets you do. So auto-scaling is going to let you always move up and move down based on the demands of your application. So I've been using this guy for one user. I'm running out of real estate, so we're going to use this guy for 100,000 users. But I realized as I was doing this deck that that's not going to work. So now we've got this guy's going to represent 1 million users, and we got to get up to 11 million. So we need something a little bit more big. So we're going to go with this guy. Oh wait, we got to cut him in half. If he's 1 million, half of him would be 500,000. So we want to get to the next level. Notice what I have here. So I've added it looks like it's complicated, but it's really not that complicated. Notice the auto-scaling groups. I just kind of made those get bigger and smaller for you. Notice I put auto-scaling groups now around my web tier. And again, I've only put 3 instances in my auto-scaling group in each availability zone, but again, that could be thousands of instances, right? I could say I want a minimum of 10 and a maximum of 1,000 or whatever it is. It doesn't matter, whatever your application needs. But there's something wrong with this particular architecture, at least in my mind. One thing I want to do, I'm going to take that load balance or the auto-scaling group, and I'm going to put it around both availability zones. So a single auto-scaling group that's going to span multiple availability zones. And that can be 2 availability zones, 3 availability zones. Whatever availability zones you have available to you in your account, as long as it's within the same region, let it span both of those. Because now I can have instances popping up in multiple availability zones for that, not just scalability, but also for that availability piece. You'll also notice that, again, I'm still showing my read replicas and my slave databases. I've added the cache in there. I've thrown in some Elasticache so that I can get those reads, the reads that are really popular. I can get them into my cache. I have also shown taking my session data and throwing it off to DynamoDB. We need automation now. I mean, this infrastructure is getting big. If we're scaling to thousands of instances, and we've got read replicas, and we've got all this, our data tier is expanding, we're doing this horizontal stuff, which is great. We're really taking advantage of all the benefits that AWS, has to offer. We need some automation to help with this process because we don't want to manage each individual piece of the tiers independently. We need some automation. So we've got some tools that help there. I'm going to start actually on the far right, which is really no tools, right? Using EC2 and automating it yourself. You can use tools like Chef or Puppet and do a lot of the automation on your own. And if that's your bread and butter and that's differentiating you as a business, then maybe that's where you want to go. I would suggest, though, that you might want to move on the continuum there and go a little bit more to the convenient side because it's going to make your life a lot easier. So let's start on the far left where we've got that convenience. The Amazon Elastic Beanstalk. That is really simple. I mean, you simply point Beanstalk to your application code, and Amazon Beanstalk manages the infrastructure necessary to run that application. Really simple, but notice not a lot of control. A lot of convenience, not a lot of control. AWS OpsWorks, that is an environment where you build your application in layers. You use chef recipes. We've got a bunch of built-in chef recipes for you to use, but you can bring your own custom chef recipes in as well to manage the layers of your application, and also provides you with some really good flexibility for doing some continuous integration and deployment and managing the life cycle of your application. And then CloudFormation. That's been the one that has been around the longest. It offers the most flexibility because it's just a templatized view of your environment, of your stack. You can use it to build. You can use this to build up an entire stack or just components of your stack. If you want to update your stack, you simply update your CloudFormation template, and it will update that one piece of your application. Lots of control, a little bit more involvement on your part, obviously, and maybe a little less convenient, but massive control. The next thing I want to talk about, though, is that we've also developed a suite of services around more around continuous integration and deployment, and just the management of your application code and getting application code from the repository, the whole life cycle, to getting it onto the instances. We've got the code pipeline, we've got the code commit, but the one I want to focus on here is the code deploy, which is the one that's going to get our application code to our instances. And again, this is a managed service that you can use to help do that automation of getting your application code out there. You can use it for getting the application code to one instance or thousands of instances. You can point your code deploy to an auto-scaling configuration so that now auto-scaling and code deploy can work together so that you're not deploying code to a single instance. You're deploying code to a group of instances that's managed by that auto-scaling group. And one other thing to mention is that this can also be used in conjunction with Chef and Puppet as well. So we get to a point where I'm going to suggest that you probably want to monitor your application all the time, but you're going to get to a point where that's not going to become an option. It's going to become a necessity. You can build your own monitoring internally. I'm going to suggest that you probably don't do that because it's a lot of work. And again, it's probably not differentiating you as a company. It's not making you money. So I would suggest that maybe you outsource it. Let somebody else handle that for you. The second bullet is really important. You need to know what your customers are saying. Like, it's great that I manage my infrastructure and I'm like, oh, CPU is great. Latency is awesome. But my customer is having a terrible experience for whatever reason. They're getting an error when they go to my web page. Well, that's a problem, or their latency is bad. So you need to make sure you focus on that. And there's a number of ways you can do it. Obviously, there's the help desk side, right? Listen to my customers. Hey, I got a problem with my application. But wouldn't it be nice if I could be a little more proactive about that? And then, of course, trying to squeeze as much performance out of what you have, your implementation. You don't want underutilized resources. Auto-scaling obviously is going to help with that. But you want to make sure that you don't have systems that are sitting there at 20% CPU utilization if they can realistically run at 80% CPU utilization. Different types of metrics for different things. Obviously there's the host level metrics. That's probably the most granular piece, right? I can look at a single EC2 instance inside of an auto-scaling group and figure out what's going on with that instance. The aggregate level instances, I think, are probably a little bit better. Maybe I'm looking at the metrics on my Elastic Load Balancer, right? So I get an idea of what is the entire, everything that the Elastic Load Balancer is responsible for, all those EC2 instances, what's going on there? That provides me another level that might be even more beneficial than just those host level metrics. You got to analyze logs, right? At some point, you've got to look at what your application, especially what the application's telling you, right? Collecting those logs. We have services that help with that. We've got CloudWatch logs that help with managing your application logs. We've got CloudTrail. We've got things that you can use to help you analyze and manage those logs. And then that last one there in the lower right, that's where I'm talking about where you have to know what your customers are seeing. And it's great to get on the phone and talk with them, but I'm suggesting that you use a service that's going to let you let you know what your application looks like as an end user. I think that the graph I've got there is from Pingdom. They do that. Maybe you're using New Relic. Maybe there's a number of partners that can help in that regard. I'm sure a number of them are out there in the expo. There's still a lot more that we can do here, though. We need to further decouple our infrastructure. And we're going to do that through SOA. So just like we did when we wanted to know what auto-scaling, how to auto-scale, when I want to know what SOA means, I'm going to pull up my web browser and my search engine and all that jazz. I'm going to type in SOA, and it's, again, going to come up with a whole boatload of suggestions. I'm going to suggest that this is not where you want to start. I'm a huge Sons of Anarchy fan, but probably not what I'm looking for here. But I am going to suggest that this is actually the right where we might want to start. This is going to tell me what I'm looking for. Service-oriented architectures. And SOAing essentially is taking components of your tiers and separating them out. So I'm creating separate, individual components that, just like I did when I separated my data from my web tier, I can now scale these independently from each other. That's going to give me huge flexibility, not just in scaling, but again in resiliency and the availability of my application. We do this intensively here at Amazon Web Services. Amazon.com does this intensively. When we build out our applications, SOA is a key component of our architectures. Don't reinvent the wheel. One of the themes that I've been giving you here is if you're engaging in a task that's not differentiating you as a customer, or not differentiating you as a business, don't do it. We've got a lot of services that are inherently fault tolerant because they span multiple availability zones, like queuing and emailing and transcoding and things like that, that you don't have to build these yourself. You can leverage these services and take advantage of that SOA and that decoupling. I've listed a few of the services here that might be able to help you, and we have others as well. SQS, for example, this is actually the first AWS service that we ever launched was SQS, and this is it spans multiple availability zones, so it's inherently fault tolerant. It's highly scalable, it's highly secure, very simple APIs to use it. And we use this example a lot, but it's a really good example of how queuing can help your infrastructure, basically passing messages between different components of your application. So if I use like a photo CMS, for example, I might have get a photo that gets brought in by a user, and I've got to do something with it. Maybe it's creating a thumbnail, maybe it's making it better resolution or lower resolution, whatever it might be. And I've got the system that's going to collect the image and the system that's going to do the work. They should be two different systems. I can scale them independently. They shouldn't be tightly coupled. So queuing allows me to do this. I can ingest the photo. I can have a queue that another set of workers goes to and says, oh, there's a message waiting in the queue. Let me pull it. Oh, there's an image sitting out in S3. I need to do something with it. It's a very simple use case, but very important, very powerful to convey the value of having SQS and the messages being sent between those distributed components of your application. AWS Lambda. Another great tool for allowing you to decouple your application. And using the same scenario as the photo CMS, Lambda can take care of that, right? I can have Lambda responding to events that are occurring inside of an S3 bucket. Hey, a user's uploaded an object into S3. I need to do something with it. What is that? Oh, I need to make a thumbnail. Put it back in S3. Really valuable. The great thing about Lambda, though, is that now you notice there's no EC2 in this architecture, right? There's no instances. Lambda is a managed service. It scales out for you, and you have absolutely no operating system to manage. So it's an awesome service for allowing you to decouple and get things done very quickly and have that SOA type architecture. Also, I had to add, in fact, I just did it a couple hours ago, threw Python on there, right? Because we just added Python as a language that now Lambda supports, and I'm sure that that's not the end. Loose coupling sets you free. I don't know who said that once, but I liked the quote, so I threw it in here. I've thrown both architectures in here because they essentially accomplish the same thing, right? If I'm doing that, if I'm using the photo CMS example, but we're designing everything as a black box so that now I can scale and fail independentally from each other. Like, do I really care if one of my worker nodes in my SQS example has a problem? No, I don't care. I'll kill it, and another instance will pick up the job and take care of it. It doesn't matter. It allows me to be infinitely scalable and handle that inevitable failure, right? Things are going to fail. Let's build an architecture then that's going to handle that. All right, we got to 1 million users. Outstanding. So this type of, we take all the stuff, if we're kind of doing a recap of everything we've been talking about so far, we can easily get to more than 1 million users with this, using the multi-availability zones, the elastic load balancer, not just on the web tier, but we can actually, if you have an architecture that's got multiple tiers, you've got your typical 3-tier, maybe you've got a web tier, an app tier, and a data tier, and you actually want to scale on the app tier as well, sure, use an ELB for that. Auto-scaling, SOA, caching off the DB, getting the state off of our web tier. And this is basically what if we were to encompass all the stuff that we've been talking about, this is what our architecture is going to look like at this point. I do need to make one comment, though. You notice I've taken out an availability zone. I really haven't. I just couldn't get it on the slide. Too much, not enough real estate. So everything you see in that single availability zone, I'd have in another availability zone, and I'd stick my load balancer right in front of it, right? So that now I've got that not just the scaling ability, but the the availability. I've thrown in Amazon SES for sending mail. I got CloudWatch there now for doing my monitoring. CloudWatch is not just for monitoring for my auto-scaling. CloudWatch is built into all of our applications, so I can monitor just about anything with CloudWatch that's happening inside the AWS infrastructure. Next big steps, getting to more than 10 million users. We're gonna run into some issues at some point as we start to get bigger, and it's likely going to be on our data tier. It's great that I've got my master database, my slave database, my read replicas. I've got the Elasticache that I'm using for the writes. That's awesome, and that's going to help a lot. But at some point, I'm going to get to a certain number of users, and I'm going to need to do something else. I'm going to need some more ability to scale, and I'm going to do that using one of those 3 methods, either using federation, using sharding, or maybe now is the time to start thinking about using some NoSQL database solutions. Database federation. I'm simply splitting my database up by different functions, right? So now in this particular example, I've got a forums database, a users database, and a products database. Whereas typically I might have had these in a single database. Now I've simply spread them out. Once again, giving me that ability to scale them independently from each other. That gives me so much more flexibility. Anytime you look at your architecture and you're like, hey, can I scale these independently? Can I decouple this and scale independently? That's gonna give me more ability to scale. It's something you really need to think about. Yes, there's some application things that have to happen here, right? My queries, that if I need to join tables between 2 different databases, it makes it a little bit more difficult. This type of scenario essentially delays my need to get to the next point, which is sharding, and I'll talk about that on the next slide. And sharding it's more complex because you got to do some more there's got to be some more application logic. But in this particular example, if I have a users database, I might be sending a third of my users to one database, the middle third to another, and the last third to another. So my application obviously has to know which, is my user M through L or A through L or M through Z, right? It has to know where to send them. But it also, like federation, gives me the ability now to again scale independently. And I can still, with federation or with sharding, I can still have my slave databases and my read replicas. It's maybe more to manage, but again, allows me to get to that beyond 10 million that I'm really looking to get to. And then that third area that I can really help with my data tier is to start thinking about a NoSQL database. And the obvious choice here is if I've got data sitting in my relational data tier that's non-relational, it's easy to pull out. Maybe it's some of those use cases that you see on the screen there. I'm not doing any complex joins, so that's great data to pull out of my relational data, put it in the NoSQL data. I might even get some better performance out of it while I have the ability to scale them again independently from each other. Lightening the load, going back to that theory as well. And lots of NoSQL databases out there, right? A whole bunch of them. And you can run them on EC2. Of course, I'm going to suggest that you use DynamoDB, again, residing in multiple availability zones, being able to tune the number of reads and the number of writes independently from each other. Lots of abilities there for performance. And you don't have to manage any sort of underlying operating system. Quick review. Again, the multi-AZ. Using self-scaling services, the Elastic Load Balancer. I didn't mention this before. I probably should have mentioned this when I was talking about the Elastic Load Balancer. It scales without you having to do anything. As the Elastic Load Balancer sees additional traffic, it scales behind the scenes, both horizontally and vertically. So you don't have to manage that. So as your application scaling, so is the Elastic Load Balancer. Amazon S3, highly performant data store for your static objects, and it's literally infinitely scalable. SNS, SQS, we've talked about those. Well, I didn't talk about SNS. SNS is our messaging platform. You can send, for example, an SMS message, or it's built in very closely with SQS and highly available. Build that redundancy at every layer. There's no reason why you have to think of scalability and redundancy in as two separate concepts, because you can often do both at the same time. Start with a traditional relational database. Start with SQL. Caching, both inside and outside of your infrastructure. What I mean by that is caching using like the CDN, caching using Elasticache. And the automation tools, right? Use something like Beanstalk or OpsWorks or CloudFormation, Chef, Puppet. Make sure you've got really good metrics, really good logging. Make sure you're finding out what your customer's experience is with your application. Again, it's not good enough to know that your application's performing great from the inside. Make sure it's performing great from the outside. SOA, splitting the tiers of your application into different components. Let them scale and fail independently from each other. Use auto-scaling, but not at the beginning. Use auto-scaling when your infrastructure is ready to use auto-scaling. Do not reinvent the wheel. If there's a managed service for what you need to do, really think about using it. It's probably the right choice. Not always. There's situations where you're doing something specific, you're doing something unique, and you've got some requirement that the managed service just can't do. I get it. But in most cases, it's going to work. Consider doing it. And then moving to a NoSQL database when it's the right time, when it makes sense for your application. Doing all this is going to get us to 10, 11, and really as far as we want to get. There's still more that we can do, though. And this is an iterative process, right? Scaling isn't something you do once. As you get bigger, there's more and more things that you need to work on, and you're going to get to certain points of your journey on scaling, and you're going to realize you still need something else. So there's always something that we're going to need to do to get to beyond 10 million, 11 million, 100 million. Maybe more fine tuning of the application. More SOA. There's this deck now is stamped on October 8th, 2015. This deck is going to be out of date tomorrow, right? There's going to be more things that aren't going to be in this deck that you're going to be able to utilize as you get bigger. You might think about going multi-region. Maybe your scalability requires that. Now, CloudFront is going to let you not go multi-region in most cases, but there may be a use case for you to go multi-region. You may need to build some custom solutions, right? I mean, if you're servicing 1 billion customers, you might need to do something specific just to your particular workload that nobody's ever done before. So you might need something like that. And then, of course, the more analysis you can do on your application stack, the better it's going to be for your ability to scale. We've got lots of documentation. Here's some that I would suggest you look at. My favorite is the one about /architecture. It's got great, not just on scaling, but it's got a whole wealth of reference architectures that might be very niche and very specific to what you guys are doing in your particular architectures, and give you just a great example of a visual 30,000-foot view of what you might want to look for. What's your end goal? And ask for help. right? Lots of places we have support, both free and paid for support. We've got forums that you can go to. Many of you have an account manager. Many of you have a solutions architect like myself. Of course, I like that picture better. So, use the resources that you have available to you.